March 3, 1937. Imperial Naval Arsenal, Kure, Japan. Commander Takeshi Fujimoto crushed his cigarette into the ashtray with more force than necessary as he stared at the classified blueprints spread across the mahogany table. The documents had arrived via diplomatic pouch from Washington just 3 days earlier, smuggled out by a sympathetic clerk in the Navy Department's Bureau of Construction. What they revealed should have sent shockwaves through every corridor of Japanese naval planning. Instead, his superiors had filed them away with a dismissive wave. The Americans were building monsters. Ships that would redefine naval warfare itself. Battleships displacing 45,000 tons, mounting 9 16-inch guns capable of hurling shells weighing as much as a small automobile across distances that defied comprehension. But it was the fire control systems that truly terrified Fujimoto. Analog computers calculating trajectories in real time. Radar systems that could track targets beyond visual range. Automated turret mechanisms that could maintain accuracy even in heavy seas. He had tried explaining to Admiral Kobayashi what these specifications meant. The old battleship commander had actually laughed, and reminded Fujimoto that Japanese night fighting doctrine and superior torpedo tactics would render such crude displays of firepower irrelevant. That conversation had been 2 weeks ago. Fujimoto had not slept properly since. The commander was not a man prone to panic or exaggeration. His record was immaculate, his calculations precise, his reputation built on cold mathematical analysis rather than emotional assessment. Which made what he was about to tell his colleagues even more difficult. Japan's entire naval strategy was based on a fundamental miscalculation. The Americans were not building conventional battleships. They were constructing floating fortresses that could destroy Japanese capital ships from ranges where return fire was physically impossible. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow, I've saved something extra special for you. Takeshi Fujimoto was born on a cold morning in November 1898 in the coastal town of Sasebo, where the gray waters of the East China Sea met the sprawling naval yards that would define his entire existence. His father operated a small chandlery supplying rope and canvas to merchant vessels, a modest business that provided just enough for the family to maintain respectability without ever achieving comfort. Young Takeshi grew up among sailors and shipwrights, learning to read the language of ships before he could properly read books. Unlike many of his peers who romanticized naval service through tales of glory and empire, Fujimoto approached the sea with a mathematician's cold eye. He excelled at the Sasebo Middle School, particularly in physics and engineering, subjects that bored most students but fascinated him with their absolute certainty. Numbers did not lie. Equations did not deceive. Mathematics revealed truth whether you wanted to see it or not. In 1916, at age 18, he entered the Imperial Japanese Naval Academy at Adajima. The institution was Japan's crucible for naval officers, a place where young men were transformed into instruments of imperial power through relentless discipline and indoctrination. But Fujimoto's instructors quickly recognized something unusual in the quiet cadet from Sasebo. While other students memorized naval doctrine and studied famous battles, Fujimoto filled notebooks with calculations about armor penetration, ballistic trajectories, and structural stress analysis. His thesis paper, submitted in his final year, caused considerable controversy. Titled Mathematical Analysis of Engagement Ranges in Modern Naval Combat, it argued that future battles would be decided not by courage or tactical brilliance but by whoever could deliver accurate fire from the greatest distance. His professors gave him top marks while privately dismissing his conclusions as overly theoretical. Real naval combat, they assured him, would always favor the warrior spirit of Japanese sailors over mere mechanical advantage. Fujimoto graduated third in his class in 1920 and received his commission as an ensign. His first assignment was to the battleship Fuso, one of Japan's most modern capital ships at the time. The posting should have thrilled any young officer, but Fujimoto spent his watches studying foreign naval journals and technical publications rather than celebrating. He noticed disturbing patterns in American and British ship design that suggested developments Japan was not matching. In 1923, The Great Kanto earthquake devastated Tokyo and Yokohama, killing over 100,000 people and destroying much of Japan's industrial infrastructure. The disaster revealed something that would haunt Fujimoto for years. American relief efforts arrived with stunning speed and scale. Ships, supplies, medical equipment, and personnel poured in with an efficiency that demonstrated organizational capacity Japan could not match. Fujimoto watched these operations with the same analytical detachment he applied to gunnery problems, and the conclusions disturbed him deeply. His opportunity to study American naval development directly came in 1928 when he was selected for advanced engineering studies at the Massachusetts Institute of Technology. The assignment was considered prestigious, a reward for outstanding service and a chance to learn modern techniques. For Fujimoto, it became an education in existential dread. He arrived in Cambridge in September 1928, carrying 2 suitcases and a head full of assumptions about American inferiority. The assumptions began crumbling within days. The campus itself was larger than most Japanese military bases. The laboratories contained equipment Japan's best facilities could not afford. The library held more technical journals than existed in all of Japan. But these were just preliminaries to the real revelation. Fujimoto's course of study focused on naval architecture and marine engineering, subjects he had mastered in Japan, or so he thought. His first assignment was to analyze stress loads on battleship hulls under combat conditions. He spent 2 weeks on calculations that would have taken months in Japan, using mechanical calculators and slide rules provided by the university. When he presented his findings, Professor Arthur Caldwell, a former Navy constructor, smiled politely and showed him the electrical calculating machines in the basement laboratory that could perform the same analysis in 3 hours. The disparity was not just technological. It was philosophical. American engineering education emphasized standardization, interchangeability, and mass production. Japanese training focused on craftsmanship and individual perfection. Both approaches could produce excellent ships, but only one could produce them quickly and in quantity. Fujimoto began to understand that modern naval warfare might be decided not by who built the best ship, but by who could build good ships fastest. His classwork was demanding, but Fujimoto made time for extracurricular education. He spent weekends touring industrial facilities around Boston, observing how Americans manufactured everything from automobiles to artillery shells. The Watertown Arsenal particularly fascinated him. The facility produced heavy guns using assembly line techniques, with interchangeable parts manufactured to tolerances that Japanese arsenals considered impossible for such large components. He watched workers, ordinary Americans without specialized training, operating machines that could bore rifle barrels to precise specifications. The entire process was mechanized, measured, and standardized. A gun barrel that would take skilled Japanese craftsmen 2 weeks to produce rolled out of the Watertown facility every 6 hours. The implications were staggering. In a prolonged war, American industry could replace losses faster than Japan could inflict them. During the summer break of 1929, Fujimoto traveled to the Philadelphia Naval Shipyard, using contacts from MIT to arrange an unofficial tour. What he witnessed there would define his understanding of American naval capacity for the rest of his life. The yard was constructing 2 heavy cruisers simultaneously, using construction techniques he had never seen. Modular assembly allowed different sections of the ships to be built in parallel, then joined together with precision that eliminated the lengthy fitting process Japanese yards required. The electrical systems particularly amazed him. Every circuit was standardized, every component interchangeable. A damaged fire control system could be replaced in hours rather than weeks because spare units were mass-produced to identical specifications. Japanese ships, by contrast, had systems custom-built for each vessel, making repairs slow and replacement parts scarce. He spent an afternoon in the shipyard's planning office, where civilian engineers used something called critical path method to schedule construction. They had calculated every step of the building process, identified bottlenecks, and optimized workflow to minimize delays. The ships would be completed in 32 months from keel laying to commissioning. Japanese yards needed 48 months for equivalent vessels. But it was a conversation with the yard's superintendent, a gruff former sea captain named Morrison, that crystallized Fujimoto's fears. Over coffee in the shipyard office, Morrison casually mentioned that the facility could triple its output if war came. The workers, the machinery, the supply chains, everything was designed for expansion. Right now we're running at peacetime efficiency, Morrison explained. But flip the switch to wartime production and we could build 3 ships for every one we make now. Fujimoto returned to MIT for his second year with notebooks full of observations and a growing sense of doom. He began collecting data obsessively, not just about ships but about American industrial capacity in general. Steel production, electrical generation, machine tool manufacturing, everything that contributed to military potential. The numbers painted a picture that contradicted everything Japanese military doctrine assumed about American weakness. His thesis project, required for completion of his MIT program, became a comprehensive analysis of comparative naval industrial capacity between Japan and the United States. The document, running to 300 pages with extensive charts and calculations, was the most thorough assessment of American shipbuilding potential ever compiled by a Japanese officer. It was also a prophecy of disaster that no one wanted to read. The core findings were brutal in their clarity. American shipyards could outproduce Japanese facilities by a factor of at least 5 to 1 in peacetime, and potentially 10 to 1 in war. American steel production exceeded Japan's by a factor of 12. American electrical generating capacity was 15 times greater. American machine tool production, the foundation of all manufacturing, was 20 times larger. But Fujimoto's analysis went beyond simple production comparisons. He examined the second-order effects that would determine naval warfare. Ammunition production, damage control equipment, replacement parts, everything needed to sustain a fleet in combat. In every category, American capacity overwhelmed Japanese capability. Most disturbing was his analysis of what he called the replacement rate problem. Japan could build excellent warships, perhaps even better individual vessels than American yards produced. But in a war of attrition, quality mattered less than quantity. If Japan lost a battleship, replacing it would take 3 to 4 years. American yards, using their standardized construction methods, could replace an equivalent loss in 18 months. This meant that any war lasting longer than 2 years would inevitably tilt toward the side that could replace losses faster, regardless of tactical victories. The thesis was submitted in May 1930. Fujimoto received highest honors and returned to Japan in June, carrying copies of his work and a burden of knowledge he wished he did not possess. He was promoted to lieutenant commander and assigned to the Navy Technical Department, a position that should have utilized his American training. Instead, he found himself marginalized, his MIT thesis gathering dust in filing cabinets while senior officers planned for a naval future based on assumptions his research had proven false. The London Naval Treaty of 1930 had limited battleship construction, giving Japan hope that numerical disadvantages could be offset by tactical superiority. Fujimoto tried explaining that the treaty merely delayed American construction, it did not eliminate American capacity. When the treaties expired, American shipyards would resume building at rates Japan could never match. His warnings were noted, filed, and ignored. Through the early 1930s, Fujimoto watched Japanese naval planning proceed along lines he knew were suicidal. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The doctrine emphasized night engagements at close range where superior Japanese torpedo tactics could negate American firepower advantages. It assumed that American sailors, supposedly soft and undisciplined, would break under the pressure of determined Japanese attacks. It calculated that Japanese spiritual superiority would overcome material deficiencies. None of these assumptions addressed the fundamental problem Fujimoto had identified. In a prolonged war, American industry would simply overwhelm Japanese forces through sheer production capacity. Battles would be won or lost based on how quickly each side could replace destroyed ships, damaged aircraft, and expended ammunition. Japan would lose that contest catastrophically. In 1934, Fujimoto was assigned to the planning section of the Naval General Staff, a position that finally gave him access to strategic decision-makers. He immediately began preparing briefings on American industrial capacity, using updated data from technical journals and trade publications. The information confirmed his MIT research. American shipbuilding capacity had actually increased during the Depression as yards modernized with government assistance. His first major briefing came in August 1934, presented to a room full of admirals and senior captains. He laid out the mathematics of industrial warfare with the same precision he had learned at MIT. Charts showed American steel production, shipyard capacity, and electrical generation. Graphs demonstrated how quickly American industry could shift from civilian to military production. Tables compared replacement rates for different classes of warships. The reaction was polite indifference mixed with subtle hostility. Admiral Suetsugu, chief of the Naval General Staff, thanked Fujimoto for his thorough research but noted that Japanese fighting spirit and superior tactics would offset any material disadvantages. Several other officers nodded agreement. The meeting concluded with vague promises to consider the data in future planning. Fujimoto left the briefing understanding that his carefully researched warnings had changed nothing. The senior leadership had already decided on a course of action, and no amount of data would alter their convictions. They believed what they wanted to believe, and the mathematics of industrial capacity contradicted their preferred narrative. Over the following years, Fujimoto continued his efforts with increasing desperation. He published articles in naval journals analyzing American shipbuilding trends. He prepared detailed reports on new American fire control systems. He calculated how long Japan could sustain various levels of naval combat based on ammunition stockpiles and production rates. Every analysis reached the same conclusion. Japan could not win a prolonged naval war against the United States. The classified blueprints that arrived in March 1937 represented the culmination of all his fears. The Americans were building a new class of battleship that would make Japanese vessels obsolete through sheer technological superiority. The Iowa class, as the documents identified them, incorporated every advantage American industry could provide. They would be faster than any Japanese battleship, better armored, and most critically, armed with weapons systems that could engage targets at ranges Japanese ships could not match. Fujimoto spent 3 sleepless nights analyzing the specifications. The numbers were devastating. The main battery would consist of 9 16-inch guns and 3 triple turrets, similar to Japanese armament. But the American guns would fire shells weighing 2,700 pounds compared to the 2,200-pound shells of Japanese 16-inch weapons. This 500-pound difference translated into dramatically greater range and penetrating power. More important than the guns themselves was the fire control system. The blueprints described something called the Mark 8 Range Keeper, an analog computer that could calculate firing solutions accounting for on-ship motion, target motion, wind, temperature, and even the rotation of the Earth. The system could direct accurate fire at ranges exceeding 35,000 yards, nearly 20 miles. Japanese fire control systems could manage perhaps 25,000 yards under ideal conditions. The implications were simple and terrible. American battleships could engage Japanese vessels from distances where return fire would fall short. They could destroy Japanese ships without being threatened themselves. Every tactical doctrine Japan had developed, every strategy based on closing to decisive range, became irrelevant against an enemy who could kill from beyond your weapon's reach. Fujimoto prepared another briefing, this one specifically about the Iowa-class threat. He requested an emergency meeting with the Naval General Staff. The request was granted for late March, though the tone of the approval suggested his superiors expected another theoretical exercise rather than genuine strategic insight. The briefing room was less crowded this time. Only a dozen officers attended, most looking impatient to return to more pressing duties. Fujimoto began with the basics, explaining the specifications of the Iowa class as revealed in the stolen blueprints. He showed calculations of their maximum engagement range. He demonstrated how their fire control systems worked. He explained what it would mean for Japanese battleships to face enemies they could not effectively shoot back at. Admiral Kobayashi, the same officer who had dismissed his concerns weeks earlier, interrupted the presentation. "Commander Fujimoto, these are very impressive calculations. But you seem to forget that battles are won by men, not machines. Japanese sailors are superior in training and dedication. We will close the range through superior seamanship and destroy these American ships with torpedoes at night." Fujimoto, abandoning his usual deference, responded with uncharacteristic bluntness. "With respect, Admiral, the Americans will detect our approach using radar systems we cannot match. They will engage us from ranges where our guns are ineffective. Our sailors, no matter how dedicated, cannot fire shells farther than the laws of physics allow. Superior spirit does not alter ballistic trajectories." The room went silent. Such direct contradiction of a senior officer was close to insubordination. Kobayashi's face reddened, but before he could respond, another voice cut through the tension. Captain Mato Magaki, a rising star in the naval hierarchy known for strategic thinking, asked the question everyone else was avoiding. "Commander, based on your analysis, can Japan win a naval war against America once these ships are operational?" Fujimoto had known this moment would come eventually. He had rehearsed various diplomatic ways to phrase the answer. But standing in that room, facing officers who commanded the fleet he loved, serving an empire he had sworn to defend, he could not bring himself to lie or soften the truth. "No, sir. We cannot. The industrial capacity disparity is too great. If these blueprints are accurate, and I have verified them against multiple technical sources, the Americans will possess naval superiority we cannot overcome through any combination of tactics, training, or courage. The mathematics are absolute. We would be sending our sailors to die in battles they cannot win against weapons they cannot match." The briefing ended shortly after. Fujimoto was thanked for his analysis and dismissed. No decisions were made. No policies changed. The report he had prepared was classified and filed. The blueprints were returned to their secure storage. Japanese naval planning continued along the same trajectory, as if Fujimoto had never spoken at all. Walking back to his office through the corridors of the Naval Ministry, Fujimoto experienced a moment of clarity that was almost spiritual in its intensity. He had done everything correctly. Gathered the data, performed the analysis, presented the findings. But none of it mattered because the leadership had already decided what they believed. They would continue believing it regardless of evidence, continuing down a path that led inexorably to disaster. He thought about the workers he had watched at the Philadelphia shipyard, the massive cranes lifting prefabricated hull sections into place. He remembered the rows of machine tools at the Watertown Arsenal, each one capable of producing interchangeable parts with inhuman precision. He recalled Professor Caldwell's electrical calculating machines, solving in hours what took weeks by hand. All of that capacity, all of that industrial might, would soon be turned to building weapons of war. And Japan, with its limited resources and outdated manufacturing methods, would try to fight the resulting flood of steel and fire. That night, Fujimoto wrote a letter to his former professor at MIT. He could not discuss classified information, but he could share his growing sense of futility. "I have learned everything you taught me," he wrote. "I understand the mathematics of production, the principles of standardization, the power of industrial capacity. But understanding changes nothing when those who make decisions refuse to acknowledge what the numbers reveal. I see the future, Professor, and it is written in equations that no one here wants to solve." The reply came 3 months later, in Professor Caldwell's precise handwriting. "My dear Commander, mathematics is truth regardless of whether anyone accepts it. Your duty is not to make them believe, but to continue speaking truth even when it goes unheard. History will judge who was right, though I fear the proof may come at terrible cost." Fujimoto kept that letter in his desk drawer for years. He would read it during the dark days to come, when his prophecies began fulfilling themselves with mathematical precision, when the weapons he had warned about started destroying the ships he had tried to save. The letter reminded him that being right was sometimes its own punishment, especially when being right meant watching disaster unfold exactly as you had predicted. December 7, 1941. The radio message arrived at Naval General Staff Headquarters in Tokyo just after dawn. Pearl Harbor had been attacked. The American Pacific Fleet was crippled. Across Japan, celebrations erupted. Crowds gathered in city squares, waving flags and cheering the news of victory. The mighty Americans had been humbled by superior Japanese tactics and courage. In his modest office in the planning section, Commander Takeshi Fujimoto sat motionless as colleagues rushed past his door, shouting updates and congratulating each other. He did not join the celebrations. Instead, he pulled out his notebooks from MIT, the ones filled with calculations about American industrial capacity. He opened to a page he had marked years earlier, a timeline he had constructed showing how quickly American shipyards could respond to emergency war production. The mathematics were clear. Japan had perhaps 18 months before American industry reached full wartime output. After that, the flood would begin. Ships, aircraft, weapons, ammunition, all produced at rates Japan could never hope to match. The Pearl Harbor attack, tactically brilliant as it was, had not destroyed American shipyards. It had not eliminated their steel mills. It had not depleted their oil fields. All it had accomplished was guaranteeing that those resources would now be dedicated entirely to Japan's destruction. Lieutenant Yamada, one of Fujimoto's junior analysts, entered the office breathless with excitement. "Commander, have you heard? We have dealt the Americans a crushing blow. Their battleship fleet is destroyed. Surely this proves that our tactics can overcome their material advantages." Fujimoto looked up from his notebooks, his expression unreadable. "Come here, Yamada. Let me show you something." He pulled out a folder containing updated statistics on American shipbuilding capacity that he had compiled just weeks earlier. These are the shipyards at Philadelphia, Newport News, Brooklyn, and Quincy. Combined, they can produce 6 capital ships annually under peacetime conditions. Under wartime emergency production, that capacity doubles or triples. He showed another page. This is the Bethlehem Steel Fore River facility. This is New York shipbuilding. This is Mare Island on the Pacific coast. None of these were damaged today. None of their workers were killed. None of their machines were destroyed. Tomorrow morning, they will begin building replacements for every ship we sank at a rate we cannot match. Yamada's enthusiasm dimmed slightly. "But sir, we have shown them our superior fighting spirit. Surely that counts for something." Fujimoto closed the folder gently. "Spirit does not forge steel plates, Yamada. Courage does not manufacture gun barrels. Determination does not refine petroleum. I have tried for years to make people understand this. War between industrial nations is mathematics. We just solved the wrong equation." Through early 1942, Fujimoto watched Japanese forces sweep across the Pacific with a mixture of professional admiration and deep foreboding. The victories were real, the tactical execution brilliant. But he knew they were temporary, purchased with irreplaceable resources against an enemy that had barely begun to mobilize. He continued preparing reports that no one wanted to read. His analysis of Japanese oil consumption showed reserves depleting faster than anticipated. His calculations of ammunition expenditure rates revealed supply problems that would become critical within 2 years. His assessment of pilot training capacity demonstrated that Japan could not replace aircrew losses at the rate combat was inflicting them. Every report was filed. Every warning was acknowledged and ignored. The leadership was intoxicated with victory, convinced that American morale would crack before American industry could respond. Fujimoto knew better. He had walked through those factories. He had seen the systematic efficiency of American production. Morale had nothing to do with it. In April 1942, word reached Tokyo of a new American naval construction program. The specifications filtered through intelligence channels over several weeks, each detail confirming Fujimoto's worst projections. The Americans were not merely rebuilding their fleet. They were expanding it beyond anything previously attempted. The Essex-class aircraft carrier program called for building 24 fleet carriers using mass production techniques. The Baltimore-class heavy cruiser program would produce 14 ships on an accelerated schedule. Destroyer production was projected at over 100 vessels annually. And the Iowa-class battleship program, the ships Fujimoto had warned about for 5 years, was moving forward with construction at 4 different shipyards simultaneously. He requested a meeting with Admiral Nagano, Chief of the Naval General Staff. The request was granted, though scheduled for late in the day when senior officers typically dealt with administrative matters they considered peripheral to real strategic planning. Fujimoto entered the Admiral's office carrying a leather briefcase stuffed with reports and photographs. Nagano greeted him cordially enough, though the old man's impatience was obvious. "Make it brief, Commander. I have a dinner engagement with the Army Minister." Fujimoto laid out photographs of American shipyards taken by intelligence assets. "These images are from Brooklyn Navy Yard, 2 weeks ago. You can see 4 destroyers under construction simultaneously. This photograph shows the Newport News facility where the first Iowa-class battleship is being assembled. The keel was laid 5 months ago. Based on American construction schedules I studied at MIT, this ship will be operational within 30 months. Nagano glanced at the photographs without much interest. Yes, the Americans are building ships. We expected this. What is your point, Commander? My point, sir, is the rate of construction. The Americans are not building individual ships. They are operating naval production as a continuous manufacturing process, like an assembly line. Each shipyard has multiple vessels at different stages of completion. As one launches, another keel is laid. The cycle never stops. Nagano waved his hand dismissively. We are aware of American industrial capacity, Commander. But quantity alone does not guarantee victory. Our ships are superior in design and our crews are far better trained. Fujimoto took a breath, knowing he was about to cross a line from which there was no return. With respect, Admiral, that assessment is incorrect. I have analyzed the specifications of the Iowa-class battleships. They are superior to our vessels in every measurable category except perhaps torpedo armament, which is irrelevant in a gunnery duel. Now he had Nagano's full attention, though not in a positive way. The Admiral's eyes narrowed. You are suggesting that Japanese battleships are inferior to American designs? I am stating, based on mathematical analysis of armor thickness, gun caliber, fire control systems, and propulsion capability, that the Iowa class represents a qualitative leap beyond anything in the Japanese fleet. They will be faster than our fastest battleships by at least 5 knots. Their armor scheme is more efficient. And most critically, their main battery will outrange ours by approximately 7,000 yards. Nagano stood abruptly, his face flushing. Commander, you are very close to defeatist talk. I will not have officers under my command suggesting that American ships are superior to Japanese vessels. Fujimoto remained seated, his voice calm and steady. I am not suggesting anything, sir. I am reporting documented facts based on verified technical specifications. The Iowa class will mount 9 16-inch guns firing 2,700-pound armor-piercing shells to a maximum range of 42,000 yards. Our Yamato class fires 18-inch shells to a maximum range of 45,000 yards, but those ships are fewer in number and will be prioritized for fleet protection rather than forward operations. He pulled out another document. More importantly, the American fire control systems incorporate radar ranging and analog computation that makes their effective engagement range far greater than ours. They can hit targets accurately at 35,000 yards under conditions where our optical rangefinding would be ineffective. This means they can destroy our ships from ranges where we cannot accurately return fire. Nagano's anger had transformed into something colder and more dangerous. You have studied American technology extensively, Commander. Perhaps too extensively. Your conclusions seem designed to undermine confidence in Japanese capabilities. Fujimoto felt the career he had built for 2 decades crumbling beneath him, but he could not stop now. Sir, I spent 2 years at MIT studying precisely these systems. I have visited American shipyards and arsenals. I have observed their manufacturing processes. I understand their capabilities not from propaganda but from direct observation and technical analysis. Everything I am telling you is verifiable fact." The admiral sat back down, his expression unreadable. "Your dedication to technical accuracy is noted, Commander. However, I think your American education may have given you an exaggerated impression of their capabilities while diminishing your appreciation for Japanese strengths. I am reassigning you to administrative duties where your analytical skills can be applied to logistics rather than strategic assessment." The meeting ended. Fujimoto gathered his photographs and reports, understanding that he had just committed professional suicide. Within a week, he was transferred to the Navy Supply Department, relegated to managing inventory and procurement. His access to strategic planning was terminated. His security clearance was reduced. His warnings would no longer reach anyone who could act on them. But he continued compiling data anyway, working in the evenings in his small apartment, tracking American ship construction through published sources and declassified information. The numbers grew more terrifying each month. By mid-1943, American shipyards were producing escort carriers at a rate of one every 5 days. Fletcher-class destroyers rolled out of 4 different yards in a steady stream. The industrial mobilization he had predicted was exceeding even his pessimistic projections. In June 1943, intelligence reports confirmed that the first Iowa-class battleship, USS Iowa herself, had been commissioned. Within months, 3 more would join the fleet. The ships represented everything Fujimoto had warned about: mechanical perfection married to overwhelming industrial capacity. Each vessel displaced 45,000 tons, mounted armor resistant to any weapon Japan could deploy, and carried fire control systems that made them deadly at ranges Japanese battleships could not match. Fujimoto obtained technical specifications through back channels, classified documents that circulated among naval architects even if strategic planners ignored them. He spent weeks analyzing the data, confirming his worst fears. The Iowa class could sustain 33 knots for extended periods, making them faster than any Japanese battleship. Their 16-inch guns could penetrate Japanese armor at ranges where return fire would be ineffective. Their radar systems could track targets in darkness and poor weather when optical systems were useless. He prepared a final comprehensive report, knowing it would likely never be read by anyone in authority. The document ran to 400 pages, a complete technical assessment of Japanese naval capabilities versus American production. The conclusions were mathematically inevitable. Japan had already lost the naval war. What remained was simply the time required for American industrial superiority to manifest in overwhelming force. The report was submitted through proper channels in August 1943. It disappeared into the bureaucratic machinery without comment or acknowledgement. Fujimoto never received any response, never learned if anyone beyond the filing clerks had even opened it. But he had done his duty. He had warned them with every tool at his disposal, using mathematics and engineering analysis to demonstrate the futility of continued resistance. In October 1944, the Battle of Leyte Gulf provided the empirical proof of everything Fujimoto had calculated. Japanese forces committed virtually their entire remaining fleet in a desperate attempt to stop the American reconquest of the Philippines. The battle raged across several days and multiple engagements, the largest naval battle in history. Fujimoto was not present, still relegated to supply duties in Tokyo. But he received reports as they filtered back, each one confirming his predictions with brutal precision. Japanese ships were detected by American radar long before visual contact. American aircraft carriers, the Essex-class vessels whose production he had documented, launched strikes with hundreds of planes. American battleships, including the Iowa-class ships, engaged Japanese vessels from ranges that nullified Japanese gunnery advantages. The Japanese fleet was annihilated. 4 aircraft carriers sunk. 3 battleships destroyed, including the mighty Musashi, sister ship to Yamato. 10 cruisers lost. The Imperial Navy ceased to exist as an effective fighting force. The predictions Fujimoto had made 7 years earlier, the warnings he had based on MIT calculations and Philadelphia shipyard observations, had manifested exactly as mathematics demanded. He learned that USS Iowa herself had not participated in the main battle, being assigned to carrier escort duties. But her sister ships, New Jersey and Wisconsin, had demonstrated exactly the capabilities Fujimoto had warned about. They had engaged Japanese vessels from beyond effective return fire range. Their radar-directed guns had hit targets that Japanese optical systems could barely see. Their heavy armor had shrugged off hits that would have crippled Japanese ships. In November 1944, Fujimoto received an unexpected visitor to his supply department office. Captain Agaki, now an admiral, appeared without ceremony or advance notice. The same officer who had asked years earlier if Japan could win a naval war against America now stood in the doorway looking decades older than his actual age. They sat in silence for several minutes before Agaki spoke. "You were right, Commander. About all of it. The industrial capacity, the Iowa-class capabilities, the mathematics of attrition. Everything you warned us about has come to pass exactly as you predicted." Fujimoto felt no satisfaction in the acknowledgement, only a deep weariness. "The truth was always evident in the numbers, sir. I simply reported what the calculations revealed." Agaki pulled out a folder, classified documents that he should not have been sharing with a supply officer. "These are damage reports from Leyte Gulf. American battleships engaged our forces from ranges exceeding 35,000 yards. Their fire was accurate despite the distance. Our ships could barely reach them, and when we did, our shells were ineffective against their armor at such extended ranges." He showed another page. USS New Jersey fired 16-inch shells that penetrated our cruiser armor like it was paper. Each shell weighed 2,700 pounds, exactly as your reports specified 7 years ago. The fire control was radar-directed, hitting targets our crews could not even see clearly. Fujimoto looked at the reports without emotion. This was not vindication. It was tragedy confirmed by mathematics that no one had wanted to solve. "Did any of this have to happen, sir? If they had listened in 1937, could we have avoided this disaster?" Agaki shook his head slowly. "I do not know, Commander. Perhaps the momentum toward war was already unstoppable. Perhaps your data would not have changed the fundamental political decisions. But I do know that you tried to warn us. You used every tool at your disposal, every bit of knowledge from your American education. The failure was ours, not yours." The admiral stood to leave but paused at the door. "For what it is worth, Commander, your reports are now required reading at Naval Staff College. The next generation of officers will learn from the mistakes we made. They will understand that modern war is decided by industrial capacity and technical superiority, not by courage alone. Your warnings may not have saved this war, but they may prevent future catastrophes." After Agaki left, Fujimoto sat in his small office surrounded by supply requisitions and inventory reports, reflecting on the strange arc of his career. He had been trained as a warrior, educated as an engineer, employed as a prophet that no one believed. His MIT education had given him perfect foresight into a future he was powerless to prevent. The calculations had been correct. The warnings had been clear. But mathematics could not overcome institutional inertia and wishful thinking. He thought about Professor Caldwell's letter, still in his desk drawer after all these years. "History will judge who was right, though I fear the proof may come at terrible cost." The proof had indeed come, measured in thousands of sailors killed, dozens of ships sunk, an empire brought to ruin. Being right had never felt more like punishment. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.